Hi, everybody. All right, we're going to go through the review worksheet for the test tomorrow. All right. Number 1, solve the equation. I don't know why those absolute values are like that, but anyways, should say absolute value of x equals -4. So, what do we know about absolute value? Absolute value is always positive. So because this says the absolute value, or should say the absolute value of x equals -4, that's not possible. Remember that the absolute value is a distance. A number is from 0. So there's no such thing as a negative distance. So your answer here is just going to be no solution. On the test, if you want to just circle the negative, or just write can't be negative, that would suffice for work. All right, now we're going to go to the second problem. Okay, so absolute value of x plus 6 equals 3. Important thing to remember here on both 6.5 and 6.6, so that's most of the problems on the test until you get to graphing on a plane. Every answer will have 2 equations and 2 solutions. All right, so how do we get those 2 equations? Remember, we drop the absolute value sign and we rewrite the problem as we see it. Now we drop the absolute value sign again. We rewrite exactly what's inside. I've noticed some of you are changing the sign that's inside the absolute value sign. We do not change anything the inside. You drop, rewrite, and take the opposite. Okay? So everything's the same except for when you take the opposite of the number on the other side of the equal sign. Now you have 2 equations. Neither of those equations should have absolute value signs on them. Now you solve. So we're going to subtract 3, and remember what I told you. All the work is the same. So you can go straight across. You're subtracting 6 from both sides so that we can solve for x. So you get x equals -3. 3 plus -6, subtract, keep the sign of the larger number. Or x equals -9, because you have like signs, 2 negatives, add and keep the sign. So your solution to number 2 would be -3 and -9. Number 3, absolute value of 4x plus 2 equals 3. So again, 2 equations, 2 solutions. So drop and rewrite. So you drop those absolute values. You rewrite the problem just the way you see it. Then you drop the absolute value again. You rewrite what's inside, and you take the opposite of the following number. So that 3 becomes negative. Now we have to solve. Subtract 2 from both sides. Notice I go straight across because I'm going to just do the same work twice. So now I have 4x equals 1 and 4x equals -5. Now I have to get x by itself. I'm multiplying by 4, so I need to divide by 4. So I'm going to divide both sides by 4. When I divide both sides by 4, I get x equals 1/4, or x equals -5/4. So I see that when this prints out, it gets a little wacky. So we have to just go up and see which one that is, which it looks like A. X is 1/4 and x is -5/4. So your answer should be A. In the document I sent you, I included the answer key, so you can see that there. All right, number 3 is done. Number 4, what do we have to do to solve an absolute value equation? First and foremost, remember, is to get that absolute value by itself. Okay? Before you set up your two equations, you need to get the absolute value by itself. So here we're going to add 2 to both sides first. All right, when we add 2 to both sides, we get x, the absolute value of x minus 2 equals 9. Now the absolute value is all by itself. So now we're going to write 2 equations, 2 solutions. So we drop and rewrite. I'm going to go up here and do it. Drop, rewrite. So you get the same thing. Or drop and rewrite what's inside, not changing any signs inside the absolute value, and take the opposite of the number that follows. Now we have to solve for x. So we're going to add 2 to both sides. Here we go. So now we have x equals 9 plus 2 is 11. X equals negative 9 plus 2. Subtract, keep the sign of the larger number. So you get 11 and negative 7. Remember in school I showed you, you could put that in set notation. So it would look like this if you put it in set notation. You do not have to do that for the test. A football team scores an average of 14 points with an absolute deviation of 4 points. What were the football team's least and greatest scores? All right, so remember, I gave you the example in school about Deflategate, okay, with the Patriots. The football wasn't at the right weight, so they have a deviation when you have a football. Remember, it has to be a certain weight. I also told you they could use that in wrestling or boxing when the boxers have to weigh in. They have to be within a certain weight to be able to have the match. So this is the same thing. We can use a formula. All right. The formula, remember, is the absolute value of x minus a given number. So that's going to be in the word problem. So all you have to do is find it. And that's going to equal the absolute deviation, which is also going to be given to you. So let's look at the problem. A football team scores an average of 14 points with an absolute deviation of 4 points. There you go. What's the given number? 14 points. What's the absolute deviation? 4 points. It tells you there are only 2 numbers there. So it tells you absolute deviation. So the other one has to be the given number. Okay? Great. So now let's substitute those values into the formula. So we have the absolute value of x minus the given number, which is 14, equals the absolute deviation, which is 4. Okay? So now we just have to solve this. So again, 2 equations, 2 solutions, which we know because it already says or asks us what's the least score and the highest score. So we're going to drop and rewrite. So x minus 14 equals 4, and x minus 14 equals negative 4. Add 14 to both sides. Many of you on the quiz I gave on this while we were still in school, when was that? So long ago, switched the numbers and got negative answers. Well, think about it. That should have said ding, 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 okay? You can't have a negative distance. So that means you put the numbers in the wrong places. So if that happens on the test and you get negative answers, switch the numbers. So we get x equals 18, 4 plus 14, and x equals 10, 14 minus 4. So 18 points is the highest game, and 10 points was the score of the lowest game. Make sure to label your answer because it's a word problem. So you have to put down those points there. Awesome. Moving right along here, aren't we? All right, number 6. Absolute value of negative 3x minus 7 plus 4 is less than 3. If you read the first example, or I shouldn't say example, if you read the directions, it says solve the inequality if possible. What did I tell you when you see the word if possible? Ding, ding, ding. That means probably one of two answers, all real numbers or no solution. So let's see what's going to happen. Remember, we have to get the absolute value by itself first. So there's addition of 4 on the left-hand side. That has to get over to the other side so that the absolute value gets by itself. So we're going to subtract 4 first from both sides of the equation. So that's going to leave us with the absolute value of negative 3x minus 7 is less than negative 1. As soon as you see that negative sign, again, ding, 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 absolute value can't be negative. So what's the answer to this? No solution. There are no numbers that when you put them in for x in this equation or inequality, that's going to make that a true statement. There are none. Okay? Can't have a negative distance. Number 7. Absolute value of x plus 2 is greater than 2. Now we have inequalities and not equal signs. So this is section 6.6. It's the same as an equation, except for the fact when you write your second equation or inequality, you have to remember to flip the inequality symbol. Many of you did not do that on the last quiz, okay? Or on your homeworks that I've been looking over. When you write that second one, remember, drop, flip, opposite, okay? So first thing we ask is the absolute value by itself. Yes, it is. All right, so now we have to set up our two equations to get our two solutions. So we're going to drop the absolute value and write what's inside. So x plus 2 is greater than 2. Drop and rewrite. The first equation you write all the time or inequality is going to look exactly like the problem without the absolute value. The second one, drop and rewrite what's inside, so x plus 2. Flip the sign. Let's get a different color here. Flip the sign and take the opposite of the following number. Okay? Now we have to solve. Subtract 2. Again, all the work is the same once you write your two equations or inequalities. So x is greater than 2 minus 2 is 0. That doesn't mean there's no solution. 0 is a number. It's an answer. And x is less than negative 4. Just a reminder, what kind of inequality was the problem to begin with? A greater than. What is a greater than? That is an or statement. What does the graph look like of an or statement? Arrows in opposite directions. Okay, so remember when you graph this, that's what you should get for an answer. So we're going to put our 0 And then we're going to need another point on -4. So x is greater than 0. Open circle on 0 because it's a greater than sign, and shade to the right. X is less than -4. Open circle on -4 because there's no equal sign, and shade to the left. Make sure you graph what you've written and then check to make sure it looks like an or statement or an and statement. So that one is good. Hopefully everybody's getting these all right. All right. Number 8, solve and graph the solution. So same thing. Absolute value by itself? Yes, it is. We could actually check and see now, remember, is it an and or an or? So it's a less than, so that means it's an and. And what does that mean? That means arrows, 2 points and shade in between. Intersection, remember, intersection. All right, so now we're going to solve the inequality, the absolute value inequality. So we're going to drop and rewrite just what you see. Okay, then we're going to drop and rewrite what's inside. We're going to flip the sign. I love all these colors. And take the opposite of the following number. Okay, 2 inequalities, 2 solutions. So now we have to solve for x. So we're going to add 1 to both sides. And we have 2x is less than 4, and 2x is greater than, that's a plus, so that's -2. -3 plus 1. Subtract, keep the sign of the larger number. Now we need to divide everything by 2. The other thing we have to remember when we're doing inequalities is if we divide by a negative number, we have to reverse those inequalities. So don't forget that. Okay. So this time we divided by a positive number, so everything's staying the same. So we have x is less than 2, and we have x is greater than -1. Now if we graph it, we need our 0, -1, and 1, 2. Okay. Get my color changed here. All right. So x is less than 2. So I'm going to go put an open circle on my 2 because it's not included. And I would shade to the left. X is greater than -1. Open circle on -1 because it's not included. And greater than would be to the right. So this is an and, remember. So it's going to be an intersection. So I'm going to shade in between those 2 inequalities. Do not put arrows in between there. That would mean they continue, and it does not continue. Number 9, the absolute value of 2 minus x is less than or equal to 2. First question, what kind of inequality is it? Less than or equal to? That means, I'm going to change my color. That means an and, so you're going to have intersection. All right, now we have to set up the 2 inequalities. Drop and rewrite. 2 minus x is less than or equal to 2. And drop, rewrite. Now what? Now flip. Greater than or equal to -2. Drop, flip opposite. Okay? First one looks exactly like the one without that's given without the absolute value. Second one, drop, flip, opposite. Now solve. Subtract 2 from both sides. And we're going to get, don't forget that negative in front of that x. Negative x is less than or equal to 0. Negative x is greater than or equal to negative 4. Well, x is not by itself, so we have to divide by negative 1 to make it positive. So now we have to divide by negative 1. As soon as I put down that negative 1, ding, 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 I have to remember to flip the inequality. Do it right as soon as you put that negative down. Well, that's not flipping the inequality, is it? So let me erase that. Flip that inequality, so that one's going to become greater than or equal to, and this one is going to become less than or equal to. All right, so bring down the x, and 0 divided by negative 1 is 0. Bring down your x. Negative 4 divided by negative 1 is positive 4. So now you have x is greater than or equal to 0, and x is less than or equal to 4. So we're going to graph that on the number line. We have 0, 1, 2, 3, 4. Remember, it was an and, so we're looking for some kind of intersection. So let's see what happens. X is greater than or equal to 0. It includes the 0 this time, so we're going to shade in the circle on the 0, and greater than would be all the numbers to the right. X is less than or equal to 4, so solid circle or shaded in circle on the 4. And where do the numbers get smaller or less than 4? To the left. So what happens here? We have an intersection in between 0 and 4, so shade that in. Again, you can go back up to the top where we decided what kind of graph we should get, and we said we should get an intersection, so where we did this right. Number 10. Absolute value is by itself, so we just have to drop and rewrite. 2x minus 1 is greater than 3. It is an or, so remember arrows in opposite directions. Okay? Or 2x minus 1. What happens now? Flip less than negative 3. Drop, flip, opposite. Now solve for x, so add 1 to both sides. And we have 2x is greater than 4, and 2x is less than negative 2. Okay, now we have to divide by 2. And we get x is greater than 2, or x is less than negative 1. Okay, so now we have to graph. Kind of ran over a little bit, but we'll just graph it over here. We have 0, negative 1, and 2. Okay. So x is greater than 2 is an open circle on 2 and shade to the right. X is less than negative 1, open circle on negative 1, and shade to the left. Again, it's an or statement, so arrows should be in opposite directions. They are, so we did it right. Look at us go. All right. Number 11. Number 11 says, is the ordered pair 2, -4 a solution for the inequality 2x minus 4y is greater than 20? Many of you make this much harder than it is. You don't have to solve this equation. You don't have to graph this equation. All you need to do is substitute the values of x and y into the inequality and see if it makes a true statement. If it makes a true statement, it's a solution, which means if you did graph it and shade it, it would be shaded. Okay? If it makes a false statement, it means the point is not part of the solution. So it wouldn't be shaded if you did all the work, but you don't need to. So we know that the ordered pair is 2, -4, so that x, whoops, let me write here, x equals 2 and y equals -4. So now you're going to substitute those two values, whoops, into the inequality, okay? So 2 times x, which is 2, minus 4 times y, which is -4, is greater than 20. 2 times 2 is 4. Here's where you have to be careful. Remember that this is a -4 because it's a plus negative. Okay, so -4 times -4 is positive 16. So 4 plus 16 is greater than 20. 20 is greater than 20. Is 20 greater than 20? No. 20 equals 20. So if this said 20 is greater than or equal to 20, the answer would be yes. But because 20 is not greater than 20, then this is not a solution. So not a solution. Okay. All right, moving right along. So that all those examples were from 6.6. The next one is from 6.7. All right. So we have a graph. Y is less than or equal to 0. As soon as you see this, you should say to yourself, it only has one variable. One variable. So that means it's either vertical or horizontal. So now you have to see what variable it is. It's y. Y equals a number, remember, is a horizontal line. So we're going to go to the graph. Didn't leave myself too much room here, did I? Go to a graph. So we have x and y axis. This is your x. This is your y. And you're going to go to where y equals 0. Where does y equal 0? Well, y equals 0 on the origin or at the origin. Where else does y equal 0? Everywhere on the x-axis, because remember, it's a horizontal line. Horizontal line. So we're going to draw a horizontal line. Now, I did that kind of before I decided, but you needed to decide whether it was going to be closed or a solid line or a dashed line. So remember that the inequality was less than or equal to. So that means you have a solid line. Solid line. All right, now we're not done though, because now it's an inequality. So it wants all the values of y that are less than or equal to 0. Well, where does y get smaller? as it goes down the axis, right here, -1, -2, -3. So you're going to shade below the axis. So that is y is less than or equal to 0. Number 13. Number 13 says find the slope and y-intercept of the graph. Y is less than or equal to 4x plus 4. So y is less than or equal to 4x plus 4. It's already in slope-intercept form because y is by itself. So we don't need to do any work. So we know the slope is the coefficient of x, so that's 4. And we know y-intercept is the constant, which is right here. So that's going to be 4 also. So make sure on the test you fill those numbers in up here. Slope is 4, y-intercept is 4. Now we're going to graph. So we draw our x and y axis. 1, 2, 3, 4, 5, 6, 7. I'm going to actually make this a little bit bigger. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, -4. Okay. Then we're going to put some values on the x-axis. Okay. When you do these, which you'll have a graph on the test, so it'll be straighter and more accurate. So now we're going to graph. Where is b equal 4 on the y-axis? 1, 2, 3, 4. So we put our point. Now we're going to use our slope. M equals 4. Okay, m equals 4. I don't know why that went to below, but whatever. Remember, that's over 1, so that's going to be up and right. So 1, 2, 3, 4 over 1. We could go down 1, 2, 3, 4 and left 1. Okay? All right. Now we have to decide what kind of line. So it's a less than or equal to. It's equal to, so it's a solid line. So I'm going to draw my line. Now I have to decide where to graph, to shade, above or below. Less than means gets smaller. That's going to be below the graph. So here's your line. Where does y get smaller? As it goes down the axis. So that means you're going to shade down or below. So it should look like that. All of those points, okay, are in the solution set. Okay? We have one more. Lots of space there. I don't know what happened. Find the slope and y-intercept and graph. So now we have 3x minus 2y is greater than -14. This is not solved for y yet. So you have to make sure, in order to find the slope and the y-intercept, you have to solve for y. So make sure you solve for y. So we have 3x minus 2y is greater than -14. We're going to get y by itself, so we need to we need to subtract 3x. So we have -2y is greater than -3x minus 14. Make sure you keep the signs with the numbers. The negative is in front of the 3, it has to stay in front of the 3. There's a minus sign in front of the 14, so there has to be a minus sign in front of the 14. Now we have to divide by -2. Ding, ding, ding. We're writing down a negative number. So what do we have to do? We have to flip our sign. So make sure that that changes to a less than sign. All right, so now we are left with y is less than 2 negatives become a positive. So 3/2 x, and -14 divided by -2 is +7. Now our equation, or our inequality technically, has y by itself. So our slope, the number in front of the x, the coefficient of x, is 3/2. So remember, that means we're going to go up 3 and we're going to go right 2. Or we can go down 3 and left 2. Okay? And b is 7. Oops. B equals 7. Awesome. So now all we have to do is graph. So we're going to draw our axes. Is y. We're going to put it down here because it's 7. And there's x. So let's go 1, 2, 3, 4, 5, 6, 7. And we're going to move 1, 2, 3 there. 1, 2, 3, whatever. Okay, there we go. All right, so what do we have to do first? First, we have to plot b. B is 7, so we go to the y-axis. 1, 2, 3, 4, 5, 6, 7, and we put our point on 7. Again, some of you are putting that point on the x-axis, not the x-intercept, y-intercept. All right, now we have to use our slope, which tells us what direction to move in. So we're going to move up 3 and right 2, or down 3 and left 2. Because of my graph, the way I did it, I'm going to use the down 3 and left 2 because I have no room to go up. So down 1, 2, 3, and left 1, 2, and put my point. And I can go down 3 more. 1, 2, 3, and left 2 more. And there's my 3 points. Now, before I draw my line, I have to see what my inequality was. I believe it was less than, but I have to go back up and see. Yes. All right. So it's y is less than. So if it's less than, it means it's a dashed line because it's not included. And then it was less than, so we're going to shade below. So I take my pencil or whatever you have, dash your line, and then where does y get smaller? You can go right to the y-axis. Where does it get smaller? As it goes down this way. So that tells you where to shade. Below the line. All right. I think that was all of them. I do want to show you one other thing before I close. A quick check to see if you've shaded in the right spot is to pick the point 0, 0. Okay, so your equation was, or inequality, was y is less than 3/2 x plus 7. If I plug in 0, 0, So the 0.00. I'm going to get 0 is less than 3/2 times 0 plus 7. What does that give me? 0 is less than, what's 0 plus 7? 7. Is 0 less than 7? Yes. That means that the 0, this point, 0, should be shaded. So we can go back up to our graph, find 0, which is right here. And if I had continued to shade below the line, I would have shaded the 0. So that means I did it right. If 0 worked and you came up here and you had shaded above, okay, you wouldn't have shaded the 0, so you would have known you shaded in the wrong direction. So it's just a quick check that you can use to figure out if you shaded in the right direction. All right, video number 2 done. This is great. I hope these are helping. I'm going to do these from now on until we get back to school so that we're doing it just like we're up in class at the board. Have a great day.